Good morning. I've been doing a lot of thinking over the weekend. This is one of those times in life where it's become very self-reflective. It seems here lately I'm getting old enough now where people that pass away and that. And I just had Scott over at Baldwin. I just had Chester, and now my chiropractor just passed away this week. Passed away in his sleep, 51. And Barry was a great guy. And it's just, and people from here, it actually, Mitch knew him. My boss knows him from out at the golf course. They were out there hitting balls, and he just saw him the day that he passed away in his sleep at night. So it's something, man. But it makes you start being a little bit more reflective, doesn't it? And self-reflective. Makes you think about yourself and everything. So, with what's going on in the world and everything, it's easy to get mired down in stuff, and what I have to fight all the time, I don't know about y'all, but is just trying to keep good spirits with everything that's going on, and that's why it's so great to be a Christian, because I just need, if I'm use it a little bit, and I think about what I've got to tap into, which is my Bible and prayer and everything I've got. So this morning, that's what I'm going to do. I'm going to pray. I'm going to lift up Barry. So Barry's a good Christian guy, good guy, great guy, man. So I'm going to lift up Barry and lift all of us up. So let's get our praying out of the way, and then we'll start getting into some of this training, all right? So if you'll join with me. Father, I lift Barry up this morning. You know what a smile he always brought to everybody's face, and how many people, my goodness, that he helped out over the years, straighten them out, backs and legs and necks and everything. And so just a great guy, and we're going to miss him, Lord. And so this is those times where, as a Christian, you can say, well, he's a Christian and all that. Yeah, and that is, we know where he's going and all that and where he's going to spend eternity. But the problem is we miss him right now. So I lift his family up, Darla and his family, his wife Darla and his family, and his daughters and that. And Father, I know they're missing him. And Father, I lift up all of his relatives that are dealing with it, because it was so sudden and so shocking and unexpected. And Father, I just give praise and glory to you right now. Thank you so much for today. Thank you for a day for us to practice and learn more about our professions, and just for what you did, so that I can lift Barry up to you right now. If Jesus hadn't died on that cross, I couldn't do that. So thank you, Lord, for doing that, so that I can lift Barry up right now, and lift all the folks up in our industry, and lift this country up, and look forward to what we're going to get done today. So all of these things I ask and I say, according to the will of the one who paid it all, my brother, Jesus Christ. Amen. Cool. All right, so what we got? JP is telling me the upcoming schedule. Today we're going to do the last part of the Padmount transformer with the 9S. August 3rd, we're going to test the 5S with the Padmount. 5S right there, same installation, right, JP?
Yes.
Yep. So remember, at the church they had 2 meters there, so we're going to look at that 5S there at the church as well. So register using that button below the video player right now, so you can get on that.
Why would you want to register now?
You would want to register now because Jarrett says to register now.
Because if you register now, you will not get an email from me. I know I clog up everybody's inbox.
Oh man, I got to say that more. All right, so if you register now, you won't get emails from JP. Well, I mean, it's from me, but they're actually JP. Y'all know that. So yeah. Oh, well, I'm all for this then. It's less I got to delete those replies. So please, I see you've pulled me in now. Okay, there's skin in the game for me now. Please register. You have no idea how many email responses I have to delete every week. You have no idea. So please, register, please. Think about me a little bit. Okay, that was smart. I like the way you did that. Pull me in on that. And and the next two will complete out the that 5S. So we're going to do 5S Part 2 on the 10th and 5S Part 3 on the 17th. So please register. What are we going to do today? We'll talk a little bit about Parts 1 and 2 of this 9S install here at the church. We're going to go ahead and test the CTs. We had tested the meter. We're going to take a look at the results, and then we're going to actually talk about some things that we needed to do, some retesting, and how we got the site lined out. So it's a great learning experience. So you guys are going to like this one. So let's go ahead and get started. We're going to pick up where we left off. Remember, we had, you saw the installations. It's a 9S. It's a, excuse me, it's a Y. It's a 9S. So we made all, excuse me, man, we made all our connections. We tested the meter, but if you remember, the meter came out like 99.5 something. So it was a little low to what we would consider a pass. So that's already got us a little bit curious. So now we're going to see what happens when we get ready to test the CTs. Okay, so we can go to the next test. So we just go next test. Because we're doing the integrated site test, right? Which it goes from one to the next to the next. It's showing us our primary connections. It always shows you the color diagram before the meter test and then before the CT test, because now you have primary connections. You have to connect on the primary side to be able to test those CTs, because you're comparing the primary versus secondary current. So it's saying, okay, it looks good on the primary connections down here at the bottom of the screen. PIA, PIB, and PIC. So those are my primary connections. It's telling me I need to be on all three phases for this 9S 120 208 3-phase 4-wire system. So it's cool.
It's easy for you to say.
Yeah. So what we've got a... Okay, so not what you would really want to see when you run the test, right? So you can see we got a fail on A phase, and we follow the red to see why we got the fails, right? So we have a fail on A phase right here, and it looks like the fail is because of a phase angle error. It's showing right here, right? Because my ratio error is actually pretty small. Because look, I tested 200.64 instead of 200.5. The other ratio is really good, okay? But it's this phase angle error on A phase. B phase, I have a fail. What's the problem here? I come over here and it's my ratio. My ratio error is way, 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 way high, right? I go from 0.32 on A phase and I'm 10.18% out on B phase. Excuse me. C phase tested just fine. So I'm not liking what I see. Okay, go ahead. Fail on A and B for two different reasons, right? You follow your red. So C is a pass, but now we got to look at A and B again. So when we look at A phase, what do we see? We notice that the A phase problem is phase angle error, okay? The problem on B phase is my actual percent registration. So when I follow the red fail, red number, red fail, red number. So I got two different reasons. Here's where I will move the gold box up. Let me get it right on my glove here. There you go. So I got to get the ridge of the glove to hit those buttons. And so I got up to, so first we'll look at A phase. And A phase, this is where we talk about these flexes are positional. Okay, so you got to make sure you get them in the right position. If they're picking something up off of another phase, or they're picking up something loose in there, it can give a phase angle error on there. So that's, the ratio looks good, but it's a phase angle error. So what Jonathan's going to do is he's going to go over here and he's going to reposition the A phase, the A phase flex, okay, and move it, and we're going to retry it again. And sometimes if you've got two guys, you can even hold it, or you can put it just like he did. So now I'm going to go over here and try a retest and see what happens. So I'm going to retest. I've moved the gold box up to where when I hit retest, it'll just retest that phase. So I'm going to retest just A phase and see what happens. we still got a fail in its phase angle there.
How many degrees?
It is 1.6 degrees. And just a quick and dirty explanation on that, if you think about the parallelograms, when you're talking about testing on that, it means that we're outside of that parallelogram, right? But remember that parallelogram is skewed. So as you're going up, it's not a square, it's leaned over a parallelogram. So sometimes when you're measuring it between the angle and the amplitude, you can get outside of that. So that's where we're at right now. So you want to you're going to hold it and center it. Because remember, on one of these flex CTs, the center is the best spot that you can be in, okay? So sometimes when you got two guys here, you get a guy to hold it dead center, and we're going to retest it again on A phase and see if we can't get a good test. So we got a pass. So the other thing to consider here is, remember, we've got two services. So we got two sets of conductors are right there beside one another. And you know, and it's not like it's total insulation all the way around those cables, all the way. They have to peel them back to get them in those spade lugs, right? So you got some other magnetic fields from a different service over here, a different set of conductors going on. So sometimes you have to get good separation and try and center those flexible CTs as much as possible. So now we're going to go to B phase and see if we can't get that worked out, because on that one, though, it was the ratio that was off. So let's try that again on B phase. So now I'm going to move my box down here to B phase, and we're going to hit a retest on B phase and see what happens. The great thing about this is what meter techs fight every day out there in the field. The phase angle error here, which is just positioning of it, then we're just going to see what's going on B phase. So we got a fail on that, and we're still at, it's consistently 10% of a ratio on B phase, Jonathan. And it's also giving me a phase angle error on B phase. So we'll go back over here and take a look at the B phase. Are we right in the middle of a bunch of stuff? Of course.
Not as bad as I've seen. Did you take a look at what the load was? Did the load come off of it?
Let's take a look.
Or is it still pretty good?
Let's take a look at the load on B phase. So that's a good point. So my load on B phase is, I have 0.83 secondary amps on B phase. And I've got 36.7 primary amps. So that should be enough for us to get a good test. Let's retest it again, with him holding it dead centered there. Now it's saying possible cross-phase connection, which is usually indicative of not having enough load. So let's hit this again. Now it's saying problem low primary input.
I was repositioning.
Oh, you're repositioning? Okay. All right, so he's repositioning it. So when he did, of course, then our load went way. So you notice there, we're talking about, we're going to go over this here in a minute, a lot of little clues and things are popping up for us, right? Are things that we need to make sure for moving forward, even after this site, that we need to keep in our heads, you know, for going forward with stuff. And notice it started giving me these error messages. We've talked about this before. When it starts giving you one error message after another is usually indicative of what? No load. He was moving, repositioning stuff. So when he had done that, it thought that it had no load. So just remember, when you start getting cross phase, low primary input, polarity reversal, one after another. Remember, we've said this before, Danger Will Robinson, it's saying I don't have enough. So that's what happened here when he disconnected and moved it and was repositioning it. So then it didn't see enough. So it started giving the same error messages and same errors as if there wasn't enough load at the site. Okay. So you saw we pick up on these consistent things and we file them away, so that when we're at another site and we get those messages, then we go, oh wait, let me look and see how much load I got right here. Notice that was the first thing that Jonathan asked when I said that we had low input. He said, how much load we got? when they start seeing the messages. And that's what you would do as well out there in the field, right? Start looking to see how much load you've got. And always be cognizant of that. If the load's too low, we're going to have problems testing that site, okay? Thanks, JP. Way down, right? It wasn't seeing much at all. And we've mentioned this before. When I get those, if I get one error after another out there testing, I get a cross-phase connection, low primary current input, and polarity reversal. If I see all three of those go bing, bing, bing in a row, typically for me what that means is, usually if I see that out in the field, that means I should have probably looked at my load first, but then again it could have been a load change. That is usually indicative of a very low load, okay? So the machine's saying, this just isn't going to work. It's just too low for me. And that's when you look on there and see 0.1 secondary amps or something like that. So let's try it again. So we're going to go here. Of course, we knew by getting all that we were going to get low, but see, he was repositioning, so we only got 0.14. So let's try retesting again, B phase. So now we're actually 14% ratio error. Okay, so here's where we go through this. Here we're starting with our mental Rolodex, right? So what we said was, so Jonathan changed his connections over there. This is a great training tool right here. So Jonathan changed his connections over there. You can see over here, let's walk over here. So Jonathan changed his connections up. And when he did that, what he was trying to find is it following a certain connection on this probe adapter extension cable, okay, that I've had for a long, long time. So this is something that I had. It's not a standard. Troubleshooting 101, right? So what Jonathan's doing is he's making sure he doesn't have either a bad flex or a bad probe adapter cable. Okay, so that's why he's moving. He's going to move the flex connection and see if it follows the flex. So that'll tell him it's a bad flex, right? If I'm moving, if I take the B phase flex now and I swap it with the A phase flex and I still get the 14% or whatever, then I know that's not it. Okay, but if all of a sudden I swap and put the B phase flex on there and it tests just fine, now I'm looking at that flex, right? That A phase flex might have a problem. So I would put the A phase flex over on B and test it. And if it came out again, I would think I got a problem with my flex. Or you can move your connections on your probe adapter cable and follow that and see if it follows and it's maybe in the probe adapter cable, okay? So that's what he's doing now. He's going troubleshooting 101. He's just testing the different items in the link, the connection between the test kit, and you got all the way up to where the flexes and the connections at the meter installation and test switch, right? So you're following all back and make sure it couldn't be one of those cables or one of those flexes. Thanks. That I've had for a long, long time. So this is something that I had. It's not a standard one. I had it made a long, long time ago. And clearly he's saying now about the connections he's making it's the cable. So he's connecting the cable up. And this is where when you're out in the field you can find where through either maybe something that you did to it out there in the field, you broke it, bent it, or did something to it, or a connection after a while from connecting and disconnecting a lot, pins, those pins on it, whatever it is, you might have one phase on your cable that's gone bad now. So what you have to do is, that's when you send them into us and we have to repair them for you. But for whatever reason on this one, it seems to be following it. So you want to try it again now? Okay, so let's try it again. So he's changed his connections to see if the problem is in my cable. Okay, so I'm going to retest B phase again. Possible cross phase. Yes, and I'm just getting a ratio of 1.01. Do we connected the right way here?
Oh, I switched wrong to wrong, I believe.
Okay. Yep. This is field troubleshooting, folks. This is what you do every day out there in the field. So he's swapping his connections.
Now try.
Try it again. Okay. So we're going to retest B phase. So we're still at 13% on ratio error on B phase. And we would be too far away to do an actual, to change that cable out and try a different cable, right? We don't have anything that would.
Well, on that, I changed our C phase passed. So
A and C.
So
passed.
what I did was first I changed the CT that was on C phase and put it on B. So that ruled out it's not the flex ring. So then there, instead of being on the yellow on your extension cable, I switched over to blue. So I changed it here and I changed it back there where it ties into the normal probe adapter cable. And now, since we ruled out the CT, we ruled out the extension, there's only one more to go. The short probe adapter cable.
Okay, I've got another one. So let's try the short probe adapter cable.
Just go ahead and try two right now.
Oh, I'm doing two. I don't want to change two variables.
Yeah, we'd have to back out and go into instrument transformer testing for it to rescan.
Right.
This extension cable that we keep
plus we
talking
wanna
about
change
was an
two
extra
things.
long
Plus
that
we
I
change
had
one
made.
thing.
So I was making sure that the problem wasn't in that,
Okay.
that extra long extension cable that I had made, okay, for me. So that's why
So
we're doing
this
the
is field
that we're doing.
troubleshooting 101, right? You start eliminating the possibilities. So Jonathan started with the flexes, and when he swapped the flexes, it didn't follow the flex, so it wasn't the flex problem, right? So then he tried my extension that I had, which is that long extension. So now we've actually gone to the standard probe adapter cable here, because, you know, this is, if he had tested, he made a good point a second ago, that if he had gone through 10 tests, and this was his 11th test, and this happened, then he would start looking at the CT, right? But for me, and the way my stuff rides all over the country, and I swap out with guys, because I tend to do that. I tend to be, if a guy's there and he needs something, I tend to give him stuff. So there's no telling. I may have swapped out a cable with somebody that had a bad cable out there on the road, got back in the office and forgot to go ahead and turn this into my folks. So we're going to check my cable, and this is a second probe adapter cable, the standard one that I've got, which is connecting to that extension. So let's try that and see what happens. So we're going to go retest again. Nope, it's consistent at 10% ratio error on B phase. So at this point, we start looking towards the CT. We may need to check that CT on B phase, because we don't think it's any of our connections between the machine and B phase. So this is where we've started trying to eliminate, is it us or is it the installation? And so far, wouldn't you agree, it's not looking like us. It is consistently, we've traded out to make sure it wasn't one of these cables, but we're getting a high ratio error on B phase. A and C are testing fine. So right now, here is where I would want to take a look at that CT on B phase and maybe change that and see if that's not the issue. So this is exactly what we do out in the field. We look for these problems, and by changing all of this out, we don't think that's any of our connections between here and there. And the machine tested A and C correctly and it tested those fine. So I'm not thinking it's the gear, I'm thinking it's the B phase CT. So this would be a site where you would have somebody take a look and maybe change that B phase CT and see if that doesn't correct the problem. So we may have found an issue here at this site according to what the machine's saying. Wouldn't you agree?
Yep.
Yep. All right, because that's why we're out here, right, is to find these issues. Okay, so a few things here. So we're at this point in it, and you heard the way, and I really liked what, you have to check your stuff first to make sure you don't have something that's wrong, right? So we checked all the way starting from where the flexes went around there, around the conductors in the pad mount. So we checked to make sure it wasn't that initial connection, which was the flexes. It wasn't the flexes. We swapped them. It didn't follow the flexes. Then we checked the extension, right, that I had. So we took the extension, made sure it wasn't my extension cable I had. Then we made sure it wasn't my standard probe adapter cable that connected to the extension. So you're just going down through and making, because you're getting an unusual reading coming off of the CTs, right? So we're not looking at alligator clips for the voltage at the test switch. This is a CT issue we're having here. So we're testing those connections, how we're reading from on that primary for that CT all the way back to the machine. And we didn't see anything. Here's where I should have done one more thing. Always in retrospect, right? One thing I should have checked was I should have done a burden measurement test. And if I had done a burden measurement test, then I would have seen what luckily those folks down there knew about, and they asked us to look at one more thing, and I'm going to talk about it here in a second, which is lubricant. And I am not a fan of lubricant, putting lubricant all on those jaws and everything. It eventually hardens up. It's fine going in the first time, but then when you leave it there for years and it hardens up, it's just a source of problems. And so the burden measurement test would have shown the too much resistance and burden on there, and that would have keyed us in. But then also it was the local knowledge. Once again, eyes and ears of the utility. Who is that? That's y'all. So the local guy was like, yeah, there's one more thing you ought to check. And sure enough, when we checked it, that's what we found. And we're going to talk about it here in just a second. So this would be one of them that you would bring up to the folks and report it and get them to change that out and try it out and see if that's not the problem. Okay, this is great freaking training right here, because this is field testing at its best. So remember, we have said this is a corrosive environment where we are. Okay, so keeping that in mind with the corrosion, here's what we did. Okay, sprayed down, all of you saw the before and after pictures behind the meter back here on the stabs and all on that test switch. So sprayed it down really, really well. We went from a 10% ratio error to 5. So it cut it in half. So now we're thinking we're on the right. So JP's got a great before and after there. So you saw with all the gunk on there and then with all the gunk afterwards. We were sitting there actually actuating these blades and working these blades and spraying all this down because they were very tough to work. These blades were tough to work. Okay, so we worked all these blades, but then also we pulled and sprayed, like you saw, behind that meter and sprayed all back behind there. And as we started actuating these switches and working these switches, our numbers got better. And then as we started cleaning, the numbers just kept getting better and better. Okay, thanks. Track that maybe this is a corrosion problem. So to go back to what Jonathan was saying, and this is absolutely true, the last thing that you want to have to do is have to go in there and change that spade CT in there, okay? Because that's outages, that's getting all up in there. So you would really, that's your last resort. So it looked like it was a CT, but then we said, you know, for grins and giggles, let's start. So we just initially started actuating the test switch, okay, on the CT side. Started actuating the shunt, started actuating the return. And we noticed it after we cleaned everything, that dropped it from 10 to 5, cleaning it. That dropped it from 5, and it got a little bit lower, but it still wasn't below our 3%, which this test kit is set up for 3% or lower as a pass. We started getting down into 4 and then the high 3s. So we're still going in the right direction. So that's telling us we're probably on the right track here. It's a corrosion issue, which we love that rather than having to go in there and change that CT out. So then last but not least, you come in here and you pulled the meter and you got your screwdriver. Thank you. And on B phase, loosen those screws on there and then tighten them back in. And when we did that, obviously you're working those threads on there and those connections right there. So you're working that connection right there. Come over here and take a look. We ran the test again, and now we got a pass on it. So this actually was a much better solution for the utility company. You don't have to change out that CT. It was a corrosion problem, okay? And the folks that work here a lot, that was their initial reaction was, you know what, let's go down the corrosion path first. So I'm going to hit a retest. and we get a pass again. So you can see that was the problem. It was corrosion. It was corrosion on all of the grease, and we've talked about that in another one, but I'm going to talk about it again. It was all of the grease that was in there. That just becomes a trap for everything, right? So we had the grease, then we had the corrosion at the test switch, actuating those switch handles, right? So actuating both the return and the shunt helped. And then last but not least, when we were really close, it was actually going to the screws up there behind the meter right there on B phase. When we went behind there, loosened and tightened those screws a couple of times. Now we've addressed the corrosion issue, and it pulled in and got tested correctly. So now we do not have to deal with the CT inside that transformer, because that then is a much bigger that's a bigger issue and a bigger solution, right? So this was just trying to eliminate the corrosion problems, and once we did that, it tested in fine. So if you're in one of those environments, if you're down coast or you're near places that's emitting a lot of stuff, if you've got a mill right there that's emitting a lot of stuff or whatever it is, you know that there's a lot of pollution in the area, think about that, okay? Think about your connections, and that corrosion is resistance, and that resistance is burden, and it's adding burden on there. When you get ready to test those CTs, it can cause you a problem, okay? So think about that when you're out there. So this was a good one. Common sense. It was both common sense and technical. We ran down the technical path, and we eliminated a lot of stuff, right? We did our tests, and we performed the test, and when we looked at the numbers and results, it gave us a path that we followed, and finally we got to the point where on that B phase, that CT just wasn't coming in no matter what we did. It wasn't testing correctly. And then that's when two things. One is common knowledge of the area, knowing, you know, that no, we might want to check the resistance on it. And then number two, looking at the numbers, it told us that as well. So it was telling us there's something on B phase for whatever reason it's unusual. And so we went down the corrosion path. And notice it was in stages, which I thought was really interesting. It started out at around 10, you know, and then as we started actuating switches, you know, first we clean, and then it dropped down to 5%. Then we started actuating switches, and it's like 4. And then when we tighten up the screws there on B phase, it comes in below the 3%, which was pass or fail. So it came in, and it was a lot better solution for us than having to get a crew out there and fool with that CT. So start simple. Hopefully it will become a simple solution, and you don't have to have a complex solution to a complex problem. You hopefully want to have a simple solution to a complex problem. So we try and go simple in the beginning. You know, the pickup's not on there correctly. My pulse pickup, that's why I'm not getting pulses. Versus it's not connected very well at the machine. Versus, you know, instead of saying, we got cross phasing on here, let's get a crew out here and change this whole installation out. Let's look at something simpler first. And in this case, it had got us down to the point where if it hadn't been corrosion, we definitely would have had to have pulled that CT and taken a look at that CT. So hope you got a lot out of this one. It included a lot of common sense troubleshooting, and also using the equipment really well. I will say I should have done a burden measurement on that site, because if I'd done a burden measurement, it would have pointed to that B phase that we've shown the resistance being super high, and that would have clued me in too again on that the hardening up of the lubricant and stuff on there. But one thing too I noticed, and I made a little note up here to myself, was that I like the way to always be cognizant of that load. Notice, you know, you get guys like Jonathan and Browland, those guys like that, and you guys out there that are meter techs that are out there doing this every day, all day. You learn to look for that load, right? If all of a sudden I could get a dip in load and I could get a bad test, and then the load comes back up. So always be cognizant of your load, because if you don't have enough load, it's going to be difficult to test those CTs. So if you don't have enough load there, so be sure and always look at your load. If you don't have at least a half an ohm, don't fight it. All right. So hope you guys got something out of this today. I sure did. Appreciate you letting me pray for Barry and all of us in this country beforehand. And please be careful out there. We need folks getting home to their families. All right. So get ready for the upcoming. It'll be live next week, and then I'm going to film 2 ahead, because I'll be at Glim's and then at Auburn Meter Schools.
So we'll film 2 ahead on that one. But look forward to seeing y'all next week. Thanks. God bless. Be careful out there.